Okay, welcome. Welcome, Casey and Trace and Trey. And welcome, Susie. Thanks for coming. This is actually the very last webinar of the class. And I do have some plans. We're going to be doing Chapter 13. I don't cover all of Chapter 13, just a little bit. And it's just to give you a little hints of how ANOVA works. You're not going to get into all the details, and you're not required to either in this class, just to be able to kind of use ANOVA if you can use it, but not further use it and get all the details, and also not do all of the tasks that it takes to decide if you can use it. Then after that, we'll talk about the final exam. So the main thing with the final is that I need to know when you're taking the final exam and with who are you going to take it. So if you're taking the final with the same proctor as a midterm, you can just email me saying same proctor, taking it on Wednesday or taking it on Tuesday or whatever you're taking it on by December 5th. And that's great. And I note it, and I will send out, probably on Thursday is when I'll probably be able to send it out. Haven't heard anyone taking it earlier than that, which is good because it's not written yet, but it's half written. But I have my list of people that have already sent me information, and there's still a lot more to send. So are there any questions at all about anything before we start out with ANOVA? Again, feel free to talk. Any questions at all? Okay, if there's no questions, I'm going to talk about ANOVA. And ANOVA is it's going to be the last test we do, the last hypothesis test we do in this class. And I want to remind you, because it's good for the review for the final too, is that the test that we've already done, we started out with a hypothesis test for a single population mean and a single population proportion. So if you have a question that's quantitative or a question that's yes, no, and it's just a single question with one population, that was our first hypothesis test chapter, which is chapter 9. And then we moved on to say, well, what if we got two population means? Or what if we have two population proportions? Can we do that? And yeah, we did that. That was chapter 10. And then we moved on and we said, well, what if we have a qualitative question? So a question is not yes, no, and it's not a number. It's like, what's your favorite color? And we want to study that, or maybe a few questions or a few populations. And we did that with chi-squared. And that was chapter 11. And then we moved on to say, well, what if we have two variables that we want to find out if there's a linear relationship between one and the other, and they're both quantitative. And that was regression analysis. And then we moved on, and we're here. So what we have not done, what do you guys think we have not done yet in terms of being able to handle a particular question that we might be interested in to study? What do y'all think? What's left to do?
Maybe qualitative with more than one.
Actually, we did that already. It was a good try. In chapter 11, we did a test for independence, remember?
Yes.
And that was a couple qualitatives.
Okay.
Any other thoughts? Okay, well, if you don't know, let me tell you. What we haven't done yet is, what if we are interested in more than two means? So if we want to find out if there's a difference, say, in the average salary based on race. And we're going to look at Caucasians and Hispanics. We're going to look at African Americans and Asians and maybe Native Americans and all these different races. We're going to survey them and want to find out, does it make a difference which race you're in terms of what your salary is? Okay, especially the population mean salary is what we're going to be interested in. And we don't know how to do that yet. We could do two, but we don't know how to go to more than two quantitative survey questions. Any questions on that? Or populations? Any questions on that? And that's what we're doing today. So that's one of the things that's left. And I'm going to say one of. There's others too. I didn't expect you to come up with any of the others that we're not doing in this class. Because remember, this is elementary statistics. We can only go so far. We're not testing to see if there's differences in standard deviations, for example. Okay, or looking at the difference in medians. That's another thing. Those all happen in an advanced stats class. But we will look to see what happens. How do you decide whether or not there's a difference in population means among several populations where we have more than two? And we're going to have a way of doing that, and the name of it is called ANOVA. It's a little bit confusing in terms of what it stands for. It stands for analysis of variance, even though we're testing to find out if the means are different. And this is one of these, you're just going to have to trust me that variance happens in the deep math that happens in the calculation that your black box called the calculator is going to do. But you don't have to know anything about it. All you have to do is know that we're going to use it to test means. Any questions on that so far? Any questions? Okay, so let me do an example. I want to mention also, ANOVA is really only used in kind of high-end research. So it's only used in journal articles. You're not going to see it. You're definitely not going to see ANOVA in just like a news article or something like that. You're only going to see it in a published journal. And that's where ANOVA happens. And it does happen. It definitely happens. So that's the biggie, is that it's used for technical stuff. And that's why you may have never heard of it before. But it's used all the time. And I'll also tell you the bad news. When I read articles that have ANOVA in published journals, I'd say more than half of them are done wrong. It's frustrating for me. Because it's like, hey, these are professors writing journal articles and they can't even do it right. They're not math professors, but still, they should at least understand it. So I want to give you a warning. And the warning is that you'll think you know how to do ANOVA at the end of this hour, but you won't. And you won't by the end of this class. But you'll be introduced to ANOVA. That I can tell you. Okay? So it's a little frustrating, and it'll feel like you know it, and you don't. Sorry about that. You need to take another statistics class, an advanced statistics class, to really learn it right. So I'm going to share my desktop to there it is. Okay. Okay. Welcome, Paulenzia. Thanks for coming. And yeah, we got a nice group today. So here's the question. Okay, suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, that might be something that, you know, a researcher, maybe a sociologist, might be interested in learning about. Okay, the data from the study is shown below, and I want to give you a disclaimer. I made up these numbers just to make it work for this example, but definitely this could be done. You could ask people how far they are from the nearest public library, or even better, you can ask them for their address, and then you can compute it, because they probably don't know exactly how far it is. Okay, and what we've done is we really asked them two questions. The first question is, what is your race? And we let them choose white, black, Hispanic, or other. And the second question is, how far do you live from the nearest public library? Okay, any questions? Any questions on kind of the study? Okay. Oh, it's Eric, so you're not Paula. Hi, Eric. Thanks for coming. I hope you're feeling better. I see your chat that you're not feeling well. The good news about online classes is you can come in sick and no one else will get sick. Okay? Unlike other computer viruses, we can't catch your virus. So that's a good thing. But hopefully you do get better. Okay, so the first question is, what assumptions must you make in order to perform the ANOVA test? So this is something that is a bit deep. Some of them are pretty obvious and some are not. So I'm going to start listing assumptions, if that makes sense. Maybe I'll do it in purple. So let me answer the assumption. So number one, I thought it did in purple. Oh, that is purple, I guess. Yeah, I don't like purple. Try orange. That's a little better. Okay, so number one is an assumption that we have made in the past. You will notice that for each of these data sets, we have a small sample size. When you have a small sample size, what assumption have we seen in the past that we had to make? What do you guys think?
Normal distribution.
Yeah, except that it needs to be plural. There's 4 different distributions. Do you see that?
Yes.
The distribution for the whites, for the blacks, for the Hispanics, and for the others. So each of the 4 distributions are normal. Just to note, this assumption is probably wrong. Okay, I doubt that the distribution of distance that you live from the library is normal. It's probably skewed to the right because you get some people that are, a few people that are really far, and then a lot of people live in the city and they're closer. Okay, any questions on that? So that's one we've seen before. Here's another one we've seen before. And it's the assumption we've made on everything we've done in this class. What is that? Pretty much before we even learned about normal distributions. Any thoughts?
Well, we have to assume there's no bias.
Yeah, we have to assume that the samples are representative of the population. Okay, and that can be done with simple random sampling. And that's always okay to use simple random sampling, but hopefully you've learned that it's usually impossible to do simple random sampling. So you do your best that you can do, and that is kind of like stratified or cluster, but you do it right. Any questions on that? Okay, and these are done poorly either. Poorly also. There's another one we have to assume that we haven't seen before. We have 4 different populations. In order to use ANOVA, the population standard deviations all have to be the same. They don't have to be equal, but close to equal. And again, there's no reason to believe that, but that's an assumption you have to make to be able to do ANOVA. What I've learned is most people don't do it right because they don't check the assumptions, and to check the assumptions, you need advanced statistics. You guys don't know how to check to see if the standard deviations are close to the same. Okay, you look at it, eyeball it, but that's not statistics. Okay, similarly, this one you do know is that when you have a sample size of 4, good luck. It's almost never normal. You should never do a study like this. But what I didn't want to do is take up the whole page with numbers. Okay, and we're actually going to be analyzing in our calculator. I want to spend all day on our calculator. Okay, the 4th one, okay, and the order in which I write these is not important, is that the samples are independent. That's not too hard for this study, because if you just do a survey, then one person's answer is probably not going to affect another person's answer. Is that clear? Okay, where you run into problems is if you ask one person 4 questions and you want to find out you want to try and do an ANOVA on that. That doesn't work because those would be dependent. So if everyone got asked 4 questions and you want to compare the 4 answers, that's not okay. You can't do an ANOVA on that. There are other tests that you can do that we're not going to go over in this class. Any questions on that? Okay, there's another one. So as I mentioned, it's very hard to do ANOVA right. So I'm going to show you all the things you need, but I'm not going to tell you how to actually check to make sure you got it right. Okay, another one is actually not too hard, and that is the data collection was the same for each. So that basically says when we collect this survey, the way we ask the whites is the same as the way we ask the blacks, which is the same as the way we ask the Hispanics, which is the same as the way we ask the others. Okay, and that's usually not too hard. It only gets hard if you do a study, say, if you wanted to find out, let's say, whether all states have the same average amount of college education per person, so number of years going to college, then you're not going to do that study on your own because it's too much traveling. You'd have to go to 50 different states. Instead, you'd probably hire a bunch of people. Does that make sense? So if you hired a bunch of people, you have to make sure that each of the people that you've hired is doing it the right way, doing it the same way. They're being consistent. And that's where it can get in, that's where you can get in trouble, is if you don't have like a meeting at the beginning of your study to make sure everyone is handling the study in the same way. Any questions on that? Okay, so those are the assumptions that you need to make. Sometimes you don't need to make the assumptions. Like for example, if all of your samples are sample size over 30, you don't need an assumption of normality, because the central limit theorem would tell you that you have a normal distribution, so the assumption is not necessary. Any questions on that? Okay. In our case, we have small sample sizes. There's no central limit theorem that gives you normality, that's for sure. Any questions so far? Okay. The next thing, and you're used to this, is to do what? Which really was supposed to be done before I got my data. What's the next thing in any hypothesis test?
State it.
State them, and what do you mean by it? Yeah, I want to state them, and what are we stating?
Oh, HO mean 1 equals mean 2 equals mean 3 equals mean 4.
Yeah, we need to state the null hypothesis, and we need to state the alternative hypothesis. The null hypothesis, oops, that's not equal, that's a colon, is that mu, and you could say 1, but I like W better since it tells you it's a white, equals mu B equals mu H equals mu O. Any questions on that? Any questions? Okay, then we need to write down what H1 is. Now, what's wrong with saying, well, H1 is that they're all different? Because isn't that the opposite of they're all the same? There's something wrong with that. Anyone see it? Yeah, some may be equals, Trey says, and maybe the other and Hispanics are different, and the blacks and white are the same as the others, and only Hispanic is different. And that would still be they're not all the same. So the way you state this, you don't say they're all different. You say H1 is that at least 2 of the population means distance from the library differ by race. And that is the opposite of they're all the same. At least 2 of them are different. Any questions on that idea? Okay, so here's a question. It's a tough little question. Why can't, I got this new test that I'm going to tell you, but why can't I use the old test? Why can't I just compare blacks with whites, whites with Hispanics, whites with others, Hispanics with others, blacks with others, and then blacks with Hispanics? And I compare them all, and if I find that 2 of them are different, then I can say, hey, they're not all the same. What's wrong with that? Any thoughts? Because I will tell you, that's not going to be effective. Any thoughts? I could just look at every pair and do a hypothesis test for each pair to find out if they're all the same or not. And if I get a pair that's different, then I would say, hey, they're not all the same. Any thoughts, all of you? Eric or Casey or Susan or Therese or Trey? Any thoughts? Because there's something wrong with it.
Well,
No
one
idea?
thing that strikes me is that you wouldn't know. I mean, this wouldn't have to do so much with whether or not null was true, but you wouldn't have a sense of how different they are from one another.
Yeah, but we're not going to get that from this test anyway.
Yeah, that's what I'm thinking.
Yeah, I'll tell you about that, but we're not going to get into it. Yeah, here's the problem. If we tested whites versus blacks, then there's going to be a 5% chance of a type 1 error, right? And then we tested whites versus Hispanics, we again have a 5% chance of a type 1 error. And then we tested whites versus other, and again we have a 5%. Pretty soon, that percent chance is going to become like 40%. Does that make sense? So the problem with testing each of pair individually is each time you're going to have that type 1 error probability, and they're going to add up and exacerbate themselves. You're going to end up with a very large chance of a type 1 error, which is not acceptable. Does that make some sense? So instead, we use ANOVA. And what ANOVA is going to do is it's going to kind of put all that together in one package. And if you want to learn about how it puts it together, you need to take another statistics class, because I'm not doing it. Okay, but I've learned it once, and there is math behind it, but it's pretty intense mathematics. But you can trust me that this puts it together, so that in the end, you really do have a 5% chance of a type 1 error if they're all the same and we do this study again. And that's what type 1 errors are supposed to do. Any questions so far? Okay, so the next thing I want to do is I want to use my calculator. I need to get a p-value. And hopefully you all know that the p-value is everything in this class in terms of making a decision whether to reject the null hypothesis or not. So to get that p-value, I need my calculator. And you're used to this. We're going to go to stat. I hope you're used to this. And we're going to hit enter. And what I want, I have 4 different categories, so I need to erase all 4 of these. So I'm going to clear them out. So I clear out L4, I clear out L3, I clear out L2, and I clear out L1. Then I'm going to type in the data in L1, L2, L3, L4. For the whites, it was 15. It always has trouble with the 5. There we go. And then 4 and then 11, and then 9, 3, and 2. Any questions so far? For the blacks, there was 12, 1, 6, and 6. For the Hispanics, we had 9, and then we had 17, and then 5, 14, and then 7, and 1. And then for the others, we had 18, we had 11, we had 2, and we had 8. Any questions so far? You're used to entering data. Hopefully you know how to do that. Then I go to stat again. I go over to tests. I can use the up arrow because it's a lot faster. Now this is the last day of class. This is the last test we're going to do. So as you might not be too surprised, it's the last test on the list. It says ANOVA, ANOVA. And you'll notice if you look at all these tests, we've done just about all of them now. So you should be proficient for the final exam on doing all of these tests, except for a couple. We haven't done a Lin-Reg-Tient and a couple more, but the rest of them we've basically done. Then I'm going to hit enter. This is a very different test in terms of the calculator than you're used to. There's no menu here. It just shows you ANOVA with a question, and with a parenthesis. So then we're going to type in second 1, and I recommend you follow along with me. Second, whoops, and then comma, then second 2, and then comma, and then second 3, and then comma, and then second 4. And we end the paren. Any questions on this? Okay, so that's because we had 4. If we were comparing 3, we'd have L1, L2, and L3 with commas in between. We had, let's say we were doing by United States, we'd have L1 through L50. That'd be kind of messy, but you could do it. Then I hit enter. Okay, now at this point, you should be familiar with definitely one thing, but I want to talk about one more, and that is where it says F equals 0.33 about. So F is the test statistic. So we've had a lot of different distributions in this class. So let's see, put in the chat box at least one distribution that you remember seeing that someone else hasn't already typed in. Let's see if you guys can do it, because it's a good review for the final. So type in the chat box at least one distribution that you haven't seen anyone else type in. So if you're first, by the way, you can type in the one you want to do. Otherwise, you can't use theirs. Yeah, t-test is one, or t-distribution. What other distributions? All the rest of you? So type in the chat box the distribution that we've already had, because we've had a lot of them. Yep, uniform is another one. What's another one? So Casey or Charisse or Eric? Two-prop z-test, yeah, that's not a distribution, that's a test. Does that make sense, Trace? Yeah, so what's the distribution that uses? That's a hint. It's a really important distribution. Yeah, normal. Okay, except Susie, you weren't supposed to put in two different ones. Okay, so normal we've had, and we've actually had two more. At one point there was one for everybody, but Susie chimed in twice. Ratio, we haven't had a ratio distribution that isn't such a thing, but it's a good try. Let me remind you, because they're important, because you need to know them all for the final. We have had the binomial distribution. Do you remember that happened a long time ago? That was one of the distributions. And the other distribution we have had, which I thought you'd all get because it was the most recent of all of them. and that was the chi-squared. Right? That was the most recent of all the distributions we've had. I guess t was a little more recent, but you didn't really notice it necessarily because that was what you got with regression analysis. But the chi-squared was another one. So now we have a new one called the F distribution. I'm not going to get into the advanced mathematics behind the F distribution, but you can trust me, there is a lot of it, and it's not that easy, so we're not going to do it. But we are going to, I do want you to know that we have the test statistic as F equals 0.33. Any questions on that? We have the p-value of about 0.8. So we have a p-value of 0.8. Let me go and let me go back to the question, and now we can answer everything. All right, so our p-value is 0.8. You should all know how you can take that p-value of 0.8 and come up with a an explanation, come up with a conclusion based on that p-value. So let's see if you can tell me. So what is the conclusion if the p-value is 0.8? I'll start you off with the first word, there. Any thoughts? Yeah, there is insufficient evidence. To make a conclusion about whether, and then you just restate H1, at least 2 of the population mean distances from the nearest library differ by race. Are there any questions? Any questions at all about the conclusion? Okay. Had the p-value been small, then we would say there's statistically significant evidence, and then you write the same thing to conclude that instead of make a conclusion about. Any questions on that? Again, same old stuff that we've been doing for half the class, is that when you get a high p-value, we say there's insufficient evidence to make a conclusion, and then you just state H1. Any questions at all? Okay. By the way, we shouldn't be surprised that we had a big p-value. What was our sample size for each of these? So what is the sample size? Yeah, it's too small. So for blacks, it was 4. And for other, it was 4 also. And even the whites and Hispanics, yeah, they're bigger, but there's only 6. And if there's one thing I want you to learn in this class is you should never, ever do true statistics on sample sizes of 4. Is that clear? Okay, and in fact, you really need at least how many in each category?
31.
Yeah, at least 31 to be able to have at least a decent study. At least 100 for a really good study. But at least 31 will kind of at least get you moving with the normal distribution. So a sample of 4 is ridiculously small, so don't ever do anything like that. So the only reason why I do this as an example is so you don't have to spend all day watching me type in numbers in the calculator. But in the real world, you better get a larger sample size. Any questions at all on ANOVA? So I want to let you know that again, this is ANOVA, and this is the very last example in the class. And I think before I start talking about the final, I think I want to give you the secret word of the day. And I'll stick it in the middle somewhere. I'm going to make it big. Secret word will be 2 words. And the secret word of the day is thank you. And again, I want to thank you for all of you being professional, not killing each other, okay, even though there's a lot of frustration, trying to kind of learn this material and work together online and deal with outages and all kinds of stuff. Some of you had to deal with fire evacuations, which I feel bad for y'all. Of course, we did have one wonderful thing happen, I think, although I haven't heard the news, but there's a baby born. That's always a good thing, okay, or at least usually. And but again, so the secret word for the last webinar of this class is thank you. Okay, so last chance to ask questions about ANOVA before I move on and talk about the final exam. I'll give you a moment to think. And I want to give you the big warning is that you think it's easy and you understand it, but there's a lot more to it. So for example, if you get a low p-value, you could find out there's a difference, but you don't know which ones are different. And there's another test for that we don't do in this class. Okay, the other biggie is these assumptions. It's very hard to know whether the assumptions are true or not, are valid. And that takes a lot of work. All right, so I am going to talk about the final exam now. Let me go to that one, yep. Okay, so let me remind you a few things. I'm going to go to syllabus now. So the first is the final exam must be taken by December 5th. There are no exceptions, okay? So after December 5th, you either get an F or an incomplete. And by the way, I've only in my history of this is my 23rd year of teaching, only one student has turned an incomplete into a passing grade. And that's because she gave birth during the final. So that was kind of a good excuse. And then she did that and then took the test, took the final, I think it was like a month later. Baby was a little older and then she was able to do it. Everyone else, it just doesn't work. So make sure you get this final taken by December 5th or it won't be good for you, okay? Or at least give birth, one or the other. Okay, so must be taken by December 1st. I will tell you the rules are the same as the midterm. So very easy, I don't have to spend a lot of time on it. And that is that you get a 3x5 note card. Calculator, hopefully you know by now. If you don't have a calculator, you can't pass. Do you all get that now? This isn't one of these like minor requirements to have a calculator. You have to have a calculator. So you definitely need a calculator to be able to succeed on this final exam, because problems like the one we just did, if you don't have the calculator, you're not going to get a p-value and you're not going to be able to decide whether or not you reject the null hypothesis, for example. And there's all kinds of other things you got to be able to handle. Okay, so again, calculator, 3x5 note card. I recommend extra batteries just in case a bad day happens and your batteries run out at just the wrong time. Then at least you'll have batteries to stick into it. Okay, and obviously, I think it's obvious, pencil or pen, you choose. But if you don't have anything to write with, it's really hard to pass a test. Okay, so those are the main things. The test is 2 hours. Okay, the test is 2 hours, so don't try and, say, well, I only have an hour to do it, so I'm gonna, make it shorter. It will go poorly for you, because it is kind of a long test. So the test is 2 hours, and you need to make sure that you can finish in the 2 hours, and it's still pretty long. So you must, just like the regular midterm, you must find a proctor. Using the same proctor is just fine. That's easiest for me too, because I've already done the research and made sure that they're an official person, an official proctor. So you just email me saying same proctor, and then I'll know who to send it to. If you change the proctors, that's okay too. You're allowed to do that too, in case maybe you're in a different town or something next week than you were for the midterm, and you're allowed to do that. LTCC, our library, proctors, they do it for free. So anyone who lives here or wants to come up here can get free proctoring without a problem. But don't wait until next Wednesday to get your appointment up, because they get really busy during finals week. So if you haven't already made the appointment, you should make the appointment like tomorrow. Okay, I think they're still open for another 20 minutes, but tomorrow should be fine. But I wouldn't wait till after tomorrow to find your proctor. Does that make sense? Okay. But you need to find a proctor, and if you're in a different town, you have to use a different one, or yours can't make it. I'm willing to help you, but you need to let me know really soon, or you won't be able to get it in time. I'm not going anywhere, at least I don't have any plans of going anywhere between now and next Wednesday. So I'll be answering emails and getting back to you and all that kind of stuff pretty quickly. And those of you who've worked with me know that I don't wait too long to respond. So I'm happy to help you find that proctor if you're having trouble, because I don't want that to be the reason why you don't pass the class. Okay? But if you don't take the final, you don't pass the class, period. It's just a huge part of the grade. Okay, as we can see, it's 30%. And nobody is coming up with exactly 100% in the class right now. So if you get a 0 in the final, you're below 70%, and that means you didn't pass. Okay, any questions on that? Okay, so the next thing I want to talk about are some resources and kind of what to expect. So the first one, let me go back. Kind of do an order of importance. I think the first one is this Fall 18 Final Structure 2001 DocX. What I did is I took the final exam. Okay, this font may be small, but that's okay. You'll be able to see it when you click on it. I took the final exam, just like I did with the midterm, and I erased the main details, put in some other things, and that's going to be your final, except I'm going to have the main details in there. So to let you know, problem number 1 says match the following hypotheses and estimates with the appropriate test statistic or confidence interval. Okay, it's kind of like a matching problem, but there's a I through XV. There's 15 different choices, because we have had 15 different types of tests and intervals in this class. I consider this the most important problem on the test, not just because it's a lot of points, but a lot of the other problems, that's the first step. So this test, whether you can do the first step. Also, I look at it as the most important part of the whole class, is that if you can't do this, then later on when you're doing some research in your upper division class, you won't know how to do statistics. Okay? If it's just a detail or two you need to figure out, that you can go online and figure out the details. But if you don't even know where to start, going online is going to be really hard to say, where do I start? I don't know. Google's not so good about that question. So this is how to get started. There's an A, B, C, D, E, F, G, H, and I. So there's a lot of these. All you have to do is choose the one. No explanations needed. Any questions on this? Okay, question number 2. Circle either true or false. Another A through I. So these questions are questions that say, do you understand the concepts behind and the requirements needed to do all the things that we've done in this class? Okay, any questions on that? Okay, question number 3. I have a paragraph, and then it says, state the null alternative hypothesis, find the test statistic and the p-value, state the conclusion in the context of the study, Either a type 1 error or type 2 error is relevant. Determine which one and state the repercussions, which is the damage done if this error were to happen. If you don't have damage, if you just give me a definition of a type 1 error, that's not damage. That's just a definition. So I want to hear about the damage that would be done. Okay, and then E, was the sample size large enough to use the normal distribution? Explain numerically. Okay, and then question 4. For each, write down the distribution, sketch the diagram, answer the question, determine if the normality assumption was needed. There's an A and a B on this one. Where have you seen this before? Put in the chat box, where have you seen this? You've seen this problem before. So where have you seen this problem? Yeah, on the midterm. Okay, same problem. Okay, it's not going to be the same A and B, but it's the same 4 things to do on each of them. Okay, then the next question, problem 5. I'm just going to tell you it's a question from chapter 3, 4, or 5. So probability was chapter 3, chapter 4 was expected value, standard deviation, right, for discrete distribution, and chapter 5 is continuous distributions and the uniform distribution. Question number 6 is a confidence interval question. Okay, question number 7 is going to be a hypothesis test question. You can have state a null and alternative hypothesis and find the test statistic and p-value. You're going to have to state your conclusion using a complete sentence, interpret the p-value, and talk about the normality assumption being necessary or not. Question 8 comes from chapter 2, 3, or 4. Okay. Question 9 is a regression analysis problem. You got to find R, interpret it. You need to find the equation of the regression line. You need to interpret the slope, interpret the y-intercept, and actually it says find R squared. Sorry about that. And then conduct the I-hypothesis test for the correlation. State the null and alternative hypothesis, p-value, and state your conclusion in the context of the study. So that's a chapter 12 question. Okay, number 10 and number 11 those are both more hypothesis test questions. Hypothesis testing is really important in this particular final, so be ready for it. If you can't do hypothesis testing, you won't pass. And that's the test. Again, this is all available from the Canvas site. Let me show you again where I found it. If you go to Comprehensive Final and you go to the last link, that's where I found it. Any questions so far? Okay, the next thing I want to show you is I have a little practice test. And let's see if it handles it. I may have to click this. And that's a practice final. Okay, practice final is not the same thing as saying this is the final, but this gives you some practice problems to try. Any questions on that? Okay, the next one that I want to show you. I'm not sure if you all have seen this already, but if you go to Review Applets, I have to launch it, another browser, another link, a tab. Then I have 2 things that are going to be very helpful. This practice classifying statistics problems. I think I showed you that for the midterm, but for the final, it's even more important because you're going to really have to do this. So the first thing you have to do is select which ones you want to learn. Which ones should you select? Which ones should you practice? Yeah, all of them. Select all. It's very easy to do. And hit submit. See how you do. Okay? There's hundreds of these, by the way. An atmospheric scientist is studying the relationship between the global CO2 levels and the global temperatures, which is interesting because I don't know if you know, but the global warming report just came out. Actually, it was done by the Trump administration, except Trump doesn't like it, which is interesting. But it happened. He has data of CO2 levels versus global temperatures and wants to predict the global temperature if the CO2 level becomes 290,000 parts per billion. So let's see if you can tell me, put in the chat box, which of the test or confidence intervals is this? So I'll let you read through these. Tell me which one this is. And first one to pop in, and I'll give it a shot. Type in the chat box, which do you think this is? We've had them all now. Okay, I see regressive. I don't think that's what you really mean. There's no such thing as regressive. Let's see which one it is. There's a list of these. You got to type in what's on the list, the words of what's on the list. So which is it? So type in again. It's one of these bubbles. And which one might it be? Let's see if one of you knows. So hopefully you can guess. It's okay to get it wrong. Okay, this is the time to guess. You don't want to guess on the final and get it wrong. You do want to guess and at least try, but hopefully you don't have to guess. You'll just know it. Hypothesis test for two means. Okay. So hypothesis test for the difference in two means, independent samples, that one. So let's click on it. Okay. By the way, that little icon with the frown, that's not exactly what you want to see. This is not a hypothesis test. Since you want to estimate something, please try again. Okay. If we try goodness of fit, let's try it. It's not a hypothesis test. It still doesn't work. Any thoughts? So don't pick one of the hypothesis test ones. So what do you think it might be? So the thing about this app that I wrote is it gives you kind of guidance on when. It doesn't tell you which one it is right away. It tells you what to steer away from, where your mistake might have been. So what might it be? Confidence interval between two means. Let's try that. Confidence interval for the difference in two means. We are given a value of one of the variables and want to estimate the other. Try again. So try again. And we'll get there, I promise. So what might it be? Okay, I'm going to go for Trey's prediction for a single value. And then all of a sudden you got happy. Okay, nice work. And then you can try another one. Any questions on this? Okay, yeah. So I just let you know, how many of these should you do? How many should you do? Not necessarily hundreds. If you're having fun, you could do hundreds. But I recommend do as many as you need to do until you start getting them right. So if you get to the point where you're just getting them right, maybe 5, 6 in a row, and you've got the feel for it, then you're there. Does that make sense? That could take you hundreds, but hopefully not. Hopefully you'll start getting the ideas. So that's how many you should do, is however many until you get them right. All right, let me show you the next one, and that's practice true-false questions. Okay, and I did this in JavaScript. This should work on your smartphone too. So if you're like sitting in traffic or something and you're not driving, don't do it while you're driving. But if you're a passenger, then you can pull out your smartphone and try these out. Okay, again, click on the topics that you want to work on, then hit submit. What should you click on? All of them. So I'm going to select all and hit submit. Okay, if two events that have non-zero probabilities are mutually exclusive events, then they are not independent events. True or false? What do you think? True or false? Okay, so we tried to, and that's true. Because the probability of A and B is equal to 0, and that's not the same as the probability of A times the probability of B, by definition of independence. So again, I would keep doing these until you're getting the hang of all of them and getting them right. Any questions on the true-false questions? Okay, let me show you another thing that should help you out. Let me go to our course again. And this is in week 8. Anyone notice that I put something in week 8? And that was the key to the midterm. Did anyone notice that? I was just wondering. I popped it in. I figured today's the day I'm going to make an announcement, but I actually put it in a few weeks ago. If you click on that, this gives you the full key. Okay, so what you want to do is you want to practice these problems because these are all eligible for the midterm. There's a lot of hypothesis test, confidence intervals, and other. Okay, and in fact, remember there was one problem that I told you is going to be just like the one in the midterm, or very similar. You should definitely practice that one, and I have the full key on what it should look like. And on the midterm, that was question number 1. And you'll notice I have a 1, 2, 3, and 4 for each of those. And I recommend writing it out that way. So that's another help for you to practice is now try to not read the answers until after. Do your answer and see if it matches my answer. Because this is the key, not the midterm itself. So this has the answers. Any questions on this? Any questions? Okay, so that again is another piece that should help you. I tried to pop a lot of things on that can help you out. Other things that you might want to, that I recommend is, for example, you could go to last week. Or actually this last week, is it last week? I think last week we didn't have one. We can go to this week. I haven't graded it yet. I'm going to grade it tomorrow. I'll grade a few of them, but not all of them. And you can go to this. You can go to last week. There's last week. And you can go to the discussion. Oops, that wasn't the discussion. That's another thing you can do, what I was going to show you. There's the discussion. And again, I have a full example with regression analysis because you're going to ask to do a regression analysis. Notice it's a lot of words. If you don't have a lot of words, you're probably not doing it right. So make sure you know how to put those words in on examples. And others have put examples in too, but my model is definitely one, obviously, that I would be happy if you wrote that kind of thing. And some of you also did nice job. Okay, you'll know tomorrow again. I'm going to finish grading. I graded a few of them, but today I actually taught for 8 hours of teaching, so I didn't really have much time. Didn't want to go crazy. Any questions on that? Okay, the other thing you can do is you can go to any assignment. So, for example, chapter 11. Chi-square tests, and you can practice these problems. And you can go try some. And that's more stuff. There is a lot out there for you to practice. Okay, definitely there's more than you can practice. There's so much. Are there any questions at all about what to expect on the final and how to prepare? Okay, just a couple things statistically. They've done statistics on best way to prepare for the final. What should you do? What should you do an hour before the final? An hour to maybe 30 minutes before the final. Okay, Trey, that's actually one of the worst things you can do. And they did a statistical analysis to find out, and actually they used ANOVA on different techniques people used just before the final. And cram was one of the worst. Okay, so they used ANOVA and they found out that there was a difference. And then they did another test called Tukey analysis, which we haven't done. And they found out cram was like on the lowest side. So what do you do just before the test? You get a note card, so you don't have to cram your memorization. Anyone know? Eat. No, that's actually what you do the 30 minutes before the test, but an hour before to 30 minutes before. Meditate and pray. Eric, that was number 2. That's the second best thing, which is actually a good thing too. Okay? So you're right about that. Meditate and pray was like really effective. But even better is light exercise. Like take a walk, okay, is a really good thing, okay? If you're in Tahoe taking a walk, you might freeze to death because we're getting snow. But if you're not in Tahoe, taking a walk might be a good thing. What I used to do when I was a student is I'd throw a Frisbee around with a friend. Just light exercise, very healthy. It gets your brain kind of in circulation going. And if you cram just before, you can be tired when you take the test. And that's not something you want to do, okay? And then the 30 minutes before, eat and go to the bathroom. Okay, I know that sounds crude or whatever, but actually that is important. Take care of your body the last 30 minutes just before the test is a good idea. Okay, you don't want to get to the test hungry, and you certainly don't have to, get to the test where you just are like putting your legs together because you got to go. Okay, so those are the things you want to do just before the test. The day before the test, you want to study a whole lot. That's the cram tray. Okay, I recommend, what I used to do when I was a student is I used to have a saying that if I saw the sun, I didn't study enough. So I'd wake up in the morning and I would study, and then when it got dark, I was done studying. So that's my recommendation, is to cram the day before the test. So if you're taking it Wednesday, that would be Tuesday. Okay, and maybe a few days before, depending on how much time you have. But definitely you need to do a lot of studying. And you don't study by just like, oh, I'm going to glance over stuff. You study with pencil and paper in your hand, and you work out problems that are like what I told you is going to be on the exam. And if you live near anybody that's also taking it, then you could study with that person. It's a lot more fun. And then you can kind of talk about it, and that helps memory. And if not, that's okay too. There's still, you can still do it on your own. Okay, any questions at all? Any questions? That's about all I have to say. We're a little past 7, and which is kind of a good time. I usually do these a little more than an hour. Okay, and today, again, chapter 11 was really short. I'm sorry, chapter 13 was really short to talk about. And then the final. So are there any questions at all about anything about the final or this class? This is the last webinar. It doesn't mean I'm going to stop paying attention to the class, but this is the last chance to have a full webinar devoted to this kind of thing. Okay, and then the class will close next week, and then it's over. But I'll be checking the Q&A forum. I'll be checking that often. And so pop in the Q&A forum any questions that come up as you're studying, and I will definitely answer. And it's a very easy discussion forum this week. So this is very light in terms of new material stuff. Chapter 13 is short. Even the video, the chapter 13 video is short. I think it's only like 25 minutes or something. It's much shorter than usual. So there's very little to do in terms of new material, because at this point you should be focusing on that final exam. So any questions before we say goodnight for the last time? Any questions? I'm going to unshare so that we can get to the seeing each other. Any questions at all? And as always, I'm happy to answer questions. But if you want to say goodnight, we can do that too. Okay, again, thank you, Susie. And thanks for being so involved. Thank you, Trey, and thank you, Casey. All right, thanks, Eric. Okay, and thanks, Charisse. Okay, and all of you who are watching this as an archive webinar, thanks a lot. And again, please post on the Q&A forum as any questions might come up that you might have, and I'll be happy to answer them all the way up until after Wednesday, and then the class is over. Then you have to email me because the class is gone and you won't be able to get into Canvas. Okay, any last minute questions before we say goodnight, Susie?
No, I'm sure I'll be sending some.
Okay, and I'll be answering them, you know that.
Yes, always. Thank you so much for everything, Larry. Really.
Okay, thank you, Susie. And have a good night.